So today we're going to work on describing a transformation, specifically the reflection, as it's our first one. So fully describe the transformation that maps shape A to shape B. So that means we want to know how can we start at A and go to B. Well, our first thing is we have to determine what transformation is. Well, it's the same shape and same size, but the orientation, it looks like a mirror image, so we know that it's going to be a reflection. Also, it's the only one we've done so far. But knowing what kind of transformation is really going to help us out, because that'll get you your first mark by saying that it is a reflection. I'm just putting it there because we know it's going to be reflection for both. So second thing is we want to count the amount of spaces between any point that corresponds in both diagrams, or both image and its reflection. So here, I'm going to choose these 2 points. So we have 1, 2, 3, 4 points between. So if we have 4 points between, then we're going to divide by 2 as per step 2, and we'll get 2. So this is how far the line of symmetry is from that point. So here we'll be that far away. Here we're going to be that far away. So just because those both are 2, if we did for the other point, we'd find, well, hey, it's 8, and then we divide in half, so we'd find it's 4 away. But we only need 2 points to make a line. So at this point, you could just draw connecting those points if you can't see it. And this is our line of symmetry. So what values does our line of symmetry take on? Well, it takes on all the values where y is equal to -1. So at the end, we have to state that it is a reflection, and with the line of symmetry of y or x being equal to -1. So next example we're going to work towards right now is on the right hand side. So here it's a little bit harder because we might not be able to see it. And just when we get to doing rotations, this could actually be a rotation as well, but they only ever going to say fully describe the transformation. So it's just a single transformation. So here, once you get used to doing some of these, you can start to see it. Also, you might know that we were doing some y equals ax ones. So here, this is the line y equals -x from our last video. last video. So at this point, if you start to recognize some of these lines, we know that this one is simply just a reflection about with line of symmetry y equals -x. So you could just take 1 point at a time if you want to check this, or if you ever think of a more mathematical way to do than just going, well, I think I see it, you could just test points, okay? So if you think you might have a line, so you think it might be y equals, say, x, if we are just guessing. So if we guess that it's y equals x, well, if we plug in this point here, we plug in a value of x as 1, that says our y value should be 1 in our other one. Well, it's not. It's -1. Well, what's the only one way we can do that? Well, if we want -1, what's that going to do? It's going to make our x be -1. So you can do the reverse process of substitution and try and get out what our point should be. So let's do a couple things to practice. So at this point, pause the video. When you're ready, press play, and we'll go through the answers. All right, well, welcome back. So we are going to look at fully describing these transformations that map A to B. So we notice that it's a reflection for this left one for sure, because the orientation looks like a mirror image, right? The second one, we can't really describe too much, but we could tell that we could get that shape back if we did a reflection. And the next one, well, that actually kind of looks like a rotation, but because we are in the reflection part, we know that we're going to treat it as a reflection and find just our point, or our line of symmetry. That's really what this whole part is about, is can you describe the line of symmetry if you know it's a reflection? So once again, how do we do that? Sorry. Once again, we do this by looking at 2 points, the same 2 points, and I know for this one that I have this point down here. It's going to be the same as that point. So it's 2 between. So we know that the line of symmetry is going to be halfway in between the two. It's going to be its midpoint. Then we can look at the next one. We also know it's going to have that point. They're the exact same distance away. So here we can just take a line and connect those 2 points. We do only need to do 2 of the 2 lines or 2 points to make a line. So we're going to do just that. And so that is where all the values where x is equal to 1. So we'd say a reflection with x equals 1. Next one we're looking at is this one. So we're going to pick the 2 points that lie on both. Once again, so I'm picking these 2 points first. So they're 1, 2, 3, 4 away. So that means 2 away from either side. So 1, 2. You can make a dot there. Next, we're looking at this point and this point, and it's 2 away as well. Now we have 2 points. We can connect them, find our line of symmetry, and we'll be done this problem. So we have to just look at this line. What values does it take? Well, it takes the values where y is equal to 1 this time. Lastly, looking at our third problem. So we're going to look at a little bit more mathematical of approach. So I'm just going to look at that point and that point, because I know they're the same. They're both the outsides of this almost flag shape, right? So we have our 1 point as we're going A to B. So looking at our 1 point, it's 1 and 2. And it is going, so if that is A and we're going to B, our B point is changing 2 to 1. So where does this happen? Well, we're looking for, we know it's going to be something y equals ax because it's on a slant, but our value of, say, yb and xa, okay, so that means the x point out of A is this one, and the y point out of B is this one. So what do we find? Well, we find that they're the same value, so that the only time that happens is the line y equals ax, as we have seen, or y equals x, sorry, that we've seen multiple times before. So let's just draw that line as such. So you don't actually have to draw the lines, but I always find that it can help me make sense of it later on if I have to look back at my work. And so we just say y equals x. So that finishes off describing reflections. See you in the next video.